Hello, y'all, and welcome to lesson 28, structure 3.1.2. We're going to be going a bit more over the periodic table and the electron configuration. What we're doing is we're going to talk about how the period number shows the outer energy level occupied by electrons, and we'll be able to go through elements in a group via their common number of valence electrons. Furthermore, we will deduce electron configuration for an atom up to atomic number 36 from the position on the periodic table and vice versa. Lastly, we'll talk about the number of the groups as well as four specific classifications of alkali metals, halogens, transition elements, and noble gases. Those are the only four you need to have memorized for the DP chemistry curriculum. However, I will add in a couple more that are just important and good to know. So, with that said, we're going to start off with electron configuration, which we already discussed back in lesson 10. But when we look at our periodic table, especially with our previous lesson the other day, we could look at maybe group 1 elements down here, and we notice that hydrogen, lithium, um, sodium, potassium all ended with some stuff and then S1, some stuff and then S1, some stuff then S1, some stuff then S1 for their electron configs. Now, hydrogen ended with one S1, lithium 2, sodium 3, potassium 4, but this little indicator, the S1, tells us that the outermost electrons, or the valence electrons, are, there's only one of them. That's it. There's one valence electron. It's in the s orbital. If we moved over to maybe group, let's say group 13, or even we'll say group 15 right here. In group 15, we start off with nitrogen, then phosphorus, then arsenic, and so on and so forth. So if we go through those electron configs, nitrogen, phosphorus, arsenic, nitrogen is going to end in S2P3 with some numbers here. Phosphorus is also going to have S2P3. Arsenic is also going to have S2. It will also contain 3D10 and P3. Now, when we look at their energy levels, nitrogen is going to be 2. Oops, that's not a 2. 2 and 2. Phosphorus is going to be 3 and 3. Arsenic is going to be 4 and 4. So looking at the highest energy level for nitrogen, it's 2. For phosphorus, it's 3. For arsenic, it's 4. And then looking at these orbitals from the sublevels with the highest energy levels, we can find that if we make ourselves a little chart here, valence electrons, for nitrogen n equals 2, we have 5. Phosphorus, we have 5. Arsenic, we have 5. So every element in the same group is going to have the same valence electrons, and we can find that through their electron configurations. So just for further clarification, let's make sure we can do those electron configurations. That's going to be incredibly important. And I have a little handy table here that I picked up off Cognity that reminds us of our blocks. You should be able to recognize these blocks any which way, but we can pick any element here within this and practice how we get those configurations. So why don't we go ahead and give it a shot with maybe bromine. So bromine's all the way here in period 4, group 17. So as we go through these electron configurations, what you're going to do is there's two methods. So we're going to start with the long method. We start at the top and work our way left to right like we're reading a book. So for bromine, we have 1s1, 1s2. So we're going to write 1s2. Then we finish that, we'll drop down. We go through 2s1 and 2s2, 2s2. We go all the way up to 2p6, 2p6, drop down to 3s2, go all the way get all of the 3p, 3p6, drop down, get all of 4s2, then move here, and we notice that we go to 3D, not 4D. But we contain it all, so we go to 3D10. Then we go to 4p, but we don't make it all the way. We go 4p, and we only make it to element 1, 2, 3, 4, 5. Bromine is the fifth element. So our electron configuration for bromine is as follows. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So you should be able to do that and recognize an element given its electron configuration. Uh, we can also always remember that you can do a shortened electron configuration unless otherwise given instruction. Over here, we have argon, which is the last noble gas before bromine. And argon will take the place of these element or these configurations, as that is the configuration of argon, allowing us to just write 4s2, 3d10, 4p5, and we are done. Now, the one other thing the IB wants you to be able to do is go back with that. So if I gave an element, let's do a little practice example, and I'll give a couple electron configurations. Let's say krypton, and we'll say 6s2. You should be able to find that element. So give it a shot. You can use a periodic table yourself, but krypton is right here. And so 6s2, or sorry, I might have made a mistake here. 5s2. I did make a mistake. So we'll go krypton 5s2. Krypton's right here, 5s1, 5s2. It'll be this element, which when you compare with your periodic table, you'll find that it's strontium. You could try one also, maybe even in the F block. So if you get something that ends with, you don't even have to look at the beginning of these. You can just have some whatever and end at 4f7. 4f7. And all you have to do is go into your periodic table and count through the F's, 4, 5, 6, 7. So it's going to be that element, which is gadolinium. All right. So you can start recognizing elements just based off their electron configurations and not even the whole electron configuration. You can do it via just the last part because that's the key aspect. Now, there are some transition metals we made exceptions for, like over here when we get to charged ions or we get to like copper or so on and so forth, you will have some exceptions. But without those, you should be able to recognize them anyways. The last part of this lesson is just learning some of the group names of sections of the periodic table. We'll go over the four that you need to know, and then I'll go over some extra ones just for the fun of it. So you definitely need group 1. You definitely need group 12 through 13. You definitely need group 17. You definitely need group 18. So these main four groups that you're learning are the alkali metals. These are the transition elements. This little green section, group 17, is the halogens, and group 18 is the noble gases. So those are the ones you absolutely need to know. Some fun honorable mentions, we'll call them, are going to be group 2. Oh, that is not a highlighter tool. Group 2, this period and this period, and sometimes group 16 if we're feeling up for it. So group 2 are our alkaline earth metals. Alkaline with an N, earth metals. This first block, the 4F block, is going to be our lanthanides. Lanthanides. The second block, the 5F, is going to be our actinides, named after the elephants that start this block. And then this one right here, heading oxygen, are the chalcogens. You don't need to know these four in purple for the IB. They don't really test you on them, and they will only rarely talk about them. But other than that, I hope this all helps, and I hope you have a great day.